The KSampler is where your image actually gets created. There are many variations of the KSampler or the samplers in general, but the KSampler is the most commonly used one. Everything else in the workflow, the model, the prompts, the settings, is preparation. The KSampler is where all of that comes together and turns into a result. In this chapter, we'll look at what's happening inside the KSampler and then go through every setting one by one so you know exactly what each one controls and how to use it. Before we touch any settings, let's understand the process. The KSampler receives an image or an empty canvas from the empty latent image node. If using the empty latent image node, that canvas starts empty but is then filled with random noise once it hits the KSampler. If you've ever seen TV static, that's a pretty close comparison. It's a chaotic mess with no structure or meaning. The KSampler's job is to take that noise and gradually refine it into an image that matches your prompt. It does this in multiple passes. On the first pass, vague shapes start to emerge from the static. On the next pass, those shapes get clearer, then details start to form. Edges sharpen, colors develop, textures appear. Each pass brings the image closer to a finished result. Now, every setting on the KSampler controls a different aspect of this refinement process. So let's go through them. The seed is a number that determines the starting noise pattern. That random static the process begins with isn't truly random. It's generated from this number. Why does that matter? Because if you use the same seed with the same settings and the same prompt, you'll get the exact same image every time. For example, if you generate an image with a seed of 1 and then later come back and run the workflow again with the seed still set to 1 and nothing else changed, the result will be identical. Change the seed to 2 and you'll get a completely different image, same prompt, same settings, but a different noise pattern to start from, which leads to a different result. This is useful in two ways. If you generate something you like, note the seed so you can reproduce it, or don't note the seed, just save the image and you'll have all that metadata stored. And if you want variety, just change the seed to explore different outcomes from the same prompt. Now, some people are talking about good seeds and bad seeds, and that's essentially nonsense. It's all just random, and it all depends on all the other settings. And sometimes you get a lucky generation, and sometimes you don't. Control F to generate. The setting is directly tied to the seed. It determines what happens to the seed value after each run. Fixed, the seed stays exactly where you set it. Every run produces the same image. This is useful when you're tweaking other settings and want to isolate their effect without the noise pattern changing underneath. Randomize. The seed changes to a new random value after every run. This means each generation produces a different image, which is what you want when you're exploring and trying to get a variety of results from the same prompt. You also have increment and decrement. Increment will count the seed number up by 1 each time you run, and decrement will do the opposite, count down on each run. Steps controls how many refinement passes the KSampler makes on the image. Each step takes the image from its current state and pushes it a little closer to the final result. More steps means more refinement, but also more time. The AI has more passes to add detail, clean up edges, and resolve fine features. Fewer steps means faster generation, but the image may look unfinished, soft, blurry, or lacking fine detail. There's also a ceiling to this. Going too high on steps doesn't keep improving the image forever. There's a diminishing returns. Past a certain point, the image can start to look overcooked, colors become oversaturated, and details get exaggerated. Now, most of the time for most models, more steps is not going to hurt your image, but you will waste your time. The ideal number of steps depends on the model you're using. Some models are designed to work in very few steps, as few as 4 or 8. Others need 20 or 30. Or even more to produce their best results. The documentation for your model will usually suggest a range, and from there you can experiment to find what looks best for you. CFG, or classifier-free guidance, controls how closely the AI follows your text prompt during generation. At lower values, AI treats your prompt more loosely. It's still uses it as a guide, but it gives itself more creative freedom. The results might drift from what you described, but they can sometimes feel more natural or surprising. At higher values, the AI sticks more closely to your prompt. It prioritizes matching your description as literally as possible, or at least it tries to. This sounds like it's better, but if you push CFG too high, the image usually breaks, colors blow out, contrast gets extreme, and artifacts start to appear. It just looks overbaked. The sweet spot for most workflows varies by model. Some models work best at lower values, others at higher. Most of the time you set the CFG to the recommendation of the model creators and leave it there. Bear in mind, if you set the CFG to 1, you're essentially disabling your negative prompt. These two settings, the sampler and scheduler, work together to control the technique the AI uses to refine noise into an image. Think of it this way. The process of going from static to a finished image can be done using many different mathematical approaches. Each approach takes slightly different paths through the refinement process, and they each produce subtly different results, even from the same prompt, seed, and settings. Some approaches work quickly and produce good results in fewer steps. Others are slower and more methodical, sometimes capturing finer details or producing smoother images. The sampler is the core algorithm, the specific method used to remove noise at each step. You'll see names like Euler, DPMP, P2M, DPMPP, and the others in the drop-down. Each one has its own characteristics. Again, use what the workflow or the model creator has selected. I would say the most common one is Euler these days. The scheduler controls the pace of the refinement, how much noise gets removed at each step, and how that amount changes over the course of the generation. Some schedulers remove noise evenly across all steps. Others front-load the big changes early and save the fine details for the end. Together, the sampler and scheduler define the overall character of the generation process. There is no single best combination. It depends on your model, your subject, your matter, and your personal preference. I usually describe it as the sampler is the hammer. There are a lot of different types of hammers, and the scheduler is how fast or how detailed you use this hammer. Now, the best way to learn what works is to try different combinations and see how the results change. But it's not black and white, and it's going to vary model by models. Most models will recommend a sampler and scheduler pairing in their documentation, which is a good starting point, and for 99% of use cases, you can probably stay there. Denoise. This is a big one. Denoise controls how much of the starting image the AI is allowed to change. This setting only becomes relevant when you're feeding the KSampler an existing image instead of pure noise. For example, in an image-to-image workflow, where you provide a photograph or an illustration and ask the AI to transform it in some way. Now, the denoising scale goes from 0 to 1. At 1, the AI ignores the input image entirely and generates something completely new, as if it were starting from pure noise. The original image has no influence on the result. At 0, the AI changes nothing. You get your original image back untouched. The useful range is everything in between. At low values, around 0.2 to 0.4, the AI makes gentle changes. The structure, composition, and overall look, the color of the image are mostly preserved with only subtle modifications. Well, this is good for light touch-ups, minor style adjustments, upscales. At mid values, around 0.5 to 0.7, the AI keeps the general idea of the original image, but takes significant creative liberties. It might change the style, improve details, alter colors, or reshape elements while maintaining the same basic composition, or sometimes change it. This is the range most people use for image-to-image work. At higher values, 0.8 and above, the AI makes dramatic changes, and the original image serves as only a loose suggestion, and the result can look very different from what you started with. Bear in mind, when doing image-to-image with denoising only, it looks at the color pixels that are there and not what's actually in the image. When you're building a pure text-to-image workflow with an empty latent image node, like the one we built, the denoise is set to 1 by the default. And you can leave it there. There's no existing image to preserve, so you want the AI to generate freely from scratch. So this should get you going with the KSampler.